In this video, I'm going over the application of the addition rule with the two-way table when looking at probability here. So looking at this table, notice we're talking about people surveyed on whether they wear sneakers or don't wear sneakers and wear a hat or don't wear a hat. So here now, looking into this situation, what is the probability that a person selected is wearing sneakers or wearing a hat? So the common mistake is, what is the probability that a person selected is wearing sneakers? So what is that probability? Well, there are 11 people, right? Then what is the probability? Oh, sorry, 11 out of the 25. Then what is the probability of someone wearing a hat? Well, here that is 10 out of the 25. The common mistake is people add these together and say, so then my probability is 22 out of 25. Here's why this is the common error. Because absolutely we're looking for the number of people who wear sneakers or who wear a hat. However, in doing so, notice we doubled up on a certain amount. Looking here, we already included these 8 people because again, right? How many people wear sneakers? We already included the 8 and 3. How many people wear a hat? Well, we already included the 8, right, in wearing sneakers. So we don't want to include them again. We only need the people wearing a hat who don't wear sneakers. So that's why we need to make sure that we subtract out the overlap. So really we are adding, yes, but then subtract that overlap here of 8. So that's why it's not 22. That's why this is, sorry, I'm not, sorry, 22. And then I added earlier wrong. I even put 22, my fault. It is not 21. Oh my goodness, out of 25. This is 13 out of 25. That is the probability. So here, we'll do another. What is the probability that a person selected isn't wearing a hat or sneakers? So not wearing a hat is 15 out of the 25. Or wearing sneakers. So wearing sneakers is 11 out of the 25. But remember, we need to subtract out the overlap. So what amount did we accidentally count twice here? Our 3. So notice that overlap. Isn't wearing a hat and wearing sneakers. So notice it's like we're subtracting the sneakers and wearing a hat, which is 3 out of the 25. So that's why here, so what is our probability? 23 out of 25. So here, we'll do another one. Now, if it helps too, to get your totals. So here, the name begins with A through M. So looking at our state, so 26 and 24. So we're talking about our 50 states here. So then here, population less than 4 million is 24 states and 26 states, again, representing our 50 states here. So notice just our notation. What is here? What is A? Well, we're going to let event A be. The state name begins with A through M. So what is the probability of A? So here, the probability of A is 26 out of 50. So again, here, or 52%, right? So 0.52. So again, I just want to know what is the probability of getting a state that begins with A through M. There are 26 states, right, that has the name A through M. So then the probability of B. So what is B? B is the population of the state is less than 4 million. So what is the probability of the event B? How many states? 24 out of 50, or again, 48%, 0.48 if you want to talk relative, right? So again, number of states with a population of less than 4 million, 24 out of the 50. So now here, the probability of A and B. So how many states have the name that begins with A through M and have less than 4 million? 11. 11 out of the 50. So now here's our review with our given. Remember, right? Because this represents given. So here, what is the probability of a state beginning with the name A through M, given that the population is less than 4 million? So how many states, first off, have a population less than 4 million? 24, right? Then how many of those states begin with the name A through M, letter A through M? 11 out of the 24. So now here's our review with our OR. What is the probability of A or B? So here, how many begin with A? 26, right? Out of our 50. How many have less than 4 million? 24 out of the 50. But again, we're not going to add those together, right, and say 50 out of 50. What is our overlap out of the 50 that we need to subtract, that we counted twice? The 11, our and here, 11 out of the 50. So that's why here this becomes 39 out of 50, or 78%, 0.78. So here, try this, you try here on your own and answer these two questions. And here we go. So here I'll get my total. So 14, so this is 18. This is 12, which makes sense. Yep, because we surveyed 30 teachers and students. So there's my 30. So then here, 15, 10, and 5. That's my totals here. So what is the probability that a person stretched or is 18 to 30 years old? What's the probability that a person stretched? So they stretched before the game. 18 out of the 30. Then what is the probability that a person was 18 to 30 years old? 10 out of the 30. Then what was the overlap that you need to subtract out of the 30 that you counted twice? The 9 people who stretched and are 18 to 30. So that's why here you should have gotten 19 out of 30 as your probability. So then here, what is, I'll go ahead and erase, what is the probability that a person is younger than 18 years old or didn't stretch? So younger than 18, there are 15 out of the 30, or didn't stretch, which is 12 out of the 30. But again, what was the overlap out of the 30 that you needed to subtract in this case that you counted twice? The 10 younger than 18 who did not stretch. So here now subtract. So that's why the probability here is 17 out of 30.